Welcome! In this video, you will learn how to multiply and divide basic algebraic expressions. When we multiply 3 with 2, the result is exactly 6. However, in algebraic multiplication, numbers are represented by letters, so we cannot give exact value of the multiplication. For example, multiplying a with b, in this case, a and b could take any numerical value. Therefore, you cannot tell exact value of this multiplication. Result of this multiplication is simply then written as AB. When multiplying 3 with 2, the result is 6. But result is also the same value when we multiply 2 with 3. So multiplying the number in any order produces the same answer of 6. If you multiply a with b, the result is AB, and multiplying b with a, the result is BA. Remember that a and b are both algebraic representation of numerical value. So when you multiply a with b or b with a, the BA must have the same value as AB. Therefore, they are equivalent expressions. However, convention is that we write the algebraic multiplication in alphabetical order. So even if you multiply b with a, we write this as AB, since a comes before b in the alphabetical order. Now consider multiplying a with b with another letter c. This is simply written as ABC. If we multiply a and b and with another number, let's say 2, then the general convention is that we write the number first and we follow the alphabetical order with the remaining letters a and b. Since a comes before b in alphabet, the result is now going to be written as 2ab. When multiplying 4a with 5b, this is the same thing as saying multiply 4 with a with 5 and b. In this case, we first multiply 4 with 5 to give answer of 20, and we stick the letters AB together in alphabetical order. Final answer is 20AB. Similarly, we can multiply 2 or more algebraic expressions, for example multiplying 4a with 5b and 2c. This is equivalent to multiplying 4 with 5, 2 and a, b and c together, which gives us 40abc. In algebraic multiplication, when same letters are multiplied together, their powers add up. For example, multiplying a to the power 3 with a to the power 2 is the same thing as multiplying 3 lots of a's with 2 lots of a's. So the total is 5 lots of a's. So we write this as a to the power of 5. In fact, this is true of any powers and can be generalized. So if x to the power of n is multiplied with x to the power of m, then we can simply write this as x to the power of m plus n, or n plus m. When multiplying just a with a, the assumed power on a is 1. So multiplying them gives a to the power of 2, or sometimes it's simply referred to as a square, as any power of 2 is widely known as square. And multiplying a times a gives a to the power of 3, or it's more commonly referred to as a cubed. And when multiplying 2a to the power of 2 or 2a squared with 3a, we multiply 2 with 3 to give 6 and multiply a to the power of 2 with a to give 6a to the power of 3. When multiplying 3a squared b with 5ab squared, we multiply 3 with 5 and a squared with a and b with b squared. Multiplying the numbers together gives us 15, and adding the powers on a and b gives us a to the power of 3 and b to the power of 3. So final answer is therefore 15a cubed b cubed. When you multiply minus 3a squared with 6ab, this is equivalent to multiplying minus 3 with 6 and a squared with a and b, which means multiplying minus 3 with 6 gives you minus 18, and multiplying the letters gives you a cubed b. Similarly, when multiplying minus 4a to the power of 4 and b cubed with minus 7a to the power of minus 2b, this is equivalent to multiplying minus 4 with minus 7 times a to the power of 4 times a to the power of minus 2 times b to the power of 3 times b. When multiplying minus 4 with minus 7, it gives us 28, as negative times negative results in having a positive value. The powers on A and B will add up together, so adding 4 and minus 2 is the same as subtracting 2 from 4, so the powers of A will be just 2. The student power of second B is 1, it then adds to 3 to give the power of 4 on B. When taking third power of, say, a squared, it means multiply all the content inside the bracket 3 times. In this problem, we multiply a to the power of 2 3 times, which means we can add the powers of a's together to give a to the power of 6. However, we can also get the same answer by multiplying the 2 powers together. In general, given x to the power of, say, some number n is raised to the power of m, we can simply write this as x to the power of mn or nm. This rule can be extended if there are more than 1 items inside the brackets. For example, 2a squared whole cubed. If you want to simplify 2a squared whole cubed, power on outside the bracket applies to 2 as well as a squared. 2 to the power of 3 means multiplying 2 3 lots of time, which gives us 8. And we can also multiply the powers of a to give the final answer 8a to the power of 6. Similarly, 4a cubed b squared whole square is equivalent to 4a squared a cubed whole square and b square square, as the powers of 2 applies to 4a cubed and b square as well. 4a square is multiplying 4 2 lots of times, which gives you answer 16, and powers on a and b multiplies to give the final answer 16a to the power of 6 and b to the power of 4. When dividing algebraic expression, we subtract the powers of the algebraic terms. For example, dividing a to the power of 5 by a to the power of 3. We subtract 3 from 5 and the result is therefore a to the power of 2. Another way to express this division is as a fraction. A to the power of 5 divided by a to the power of 3 is equivalent to a to the power of 5 over a to the power of 3. Note that a to the power of 5 means multiplying 5 lots of a's and a to the power of 3 means multiplying 3 lots of a's. 3 of the a's from the numerator then cancels with 3 a's from the denominator, which then leaves only 2 a's in the numerator. This is now equivalent to a squared. We can divide more complicated algebraic expression using these rules. For example, consider dividing 5a to the power of 6, b to the power of 4 by 20a to the power of 8 and b to the power of 4. 5 divides 20 4 times, so 5 cancel down to 1 and 20 cancel down to 4. There are 6 a's in the numerators and 8 a's in the denominator, so it cancels all 6 a's from the numerator but leaves only 2 a's in the denominator. There are 4 b's in the numerator and 4 b's in the denominator, so they cancel each other out altogether and b disappears from the expression. Now we can collect the surviving terms, which then gives us 1 over 4a squared. Sometimes we need to use all the rules that we discussed earlier in order to simplify algebraic expression. For example, consider simplifying this expression. Powers of 3 in the numerator applies to all the terms inside the bracket. So we start by applying the power of 3 on all the numerator terms. This gives us 8x to the power of 6 y cubed in the numerator. Now we are ready to cancel the numerator with the denominator terms. 8 cancels 8 to give 1. 1 of the x from the denominator cancels x to the power of 6 down to power 5 in the numerator. But then another x cancels it again to give the power of 4. 2 y's from the denominator cancels 2 y's in the numerator, which leaves you with only 1 y in the numerator. Remaining terms are now multiplied together to give x to the power of 4y over 4. This is also equivalent to 1 over 4 x to the power of 4y. If we have a negative sign on any one of the terms in the expression, for example, take a look at this division. In this case, we will follow the same rule as before, but we also need to take care of the negative sign in the denominator. 15 and 10 can both be divided by 5, so 15 cancels down to 3 and 10 down to 2. 2 of the u's from the numerator cancels 2 u's in the denominator, and one of the v's in the denominator cancels out the v in the numerator. Now we are ready to collect the remaining terms. This gives us 3 over minus 10v, which can also be written as minus 3 over 10v. If you find this video useful for you, please click like. If you think someone else can benefit from it, please share. And if you want to hear from me again, please do not forget to subscribe to my channel. Thanks for watching. Be sure to try the exercises to test your knowledge. I'll see you in the next part.